Hey H2, here are the notes for 13.1 day 2. So if we're going to talk about this triangle at the right, we need to match each trig function with the correct ratio. Now just a quick reminder, sine goes with opposite over hypotenuse, that's our SO. We have cosine, it goes with adjacent over hypotenuse, that's our ca. And then we have tangent, which goes with opposite over adjacent, that is our TOA. And then, just as a reminder, let's remind ourselves the reciprocals of each of these. Remember, no two cos go together, so sine is going to go with cosecant. And cosecant, if sine is opposite over hypotenuse, is then hypotenuse over adjacent. Cosine then goes with secant. Notice our S has to match with our C has to match with our S. I meant to write this as an O, my apologies. And then this is H over A because it is the reciprocal of my cosine. And then, of course, tangent is cotangent. If tangent is opposite over adjacent, that means that cotangent is adjacent over opposite. So let's look at this. If we are talking about our reference angle, and we want to know R over T. Well, R is our adjacent, and T is going to be our hypotenuse. So adjacent over hypotenuse is our cosine. So we come down here, we find that cosine matches with Roman numeral little I. All right, let's go again. R over S. R is my adjacent, S is my opposite. Which one of my trig ratios goes with adjacent over opposite? When I look, I see adjacent over opposite goes with cotangent. So that one's going to be little I as well, but it's going to be two of them. All right, let's keep going then. T over R, hypotenuse over adjacent. That's going to be secant. And then S over T, that is opposite over hypotenuse, or sine. V, or number 5, is S over R. We have opposite over adjacent. That's tangent. So that's going to be V. And by process of elimination, T hypotenuse over S, hypotenuse over O, is going to be my cosecant. All right, let's keep going here. Let me zoom in quick just so I can... Maybe that's a little bit better. It's hard to see. So we know how to set up the basic trig functions. Let's now use those to figure out our missing sides and angles. So let's write an equation involving either sine, cosine, or tangent. These are useful, but not as useful as our main three. If we want to solve for an unknown side, we're going to look at our reference angle and we're going to say, what sides do we have when we're talking about that reference angle? In this case, we have opposite. And on this side, we have adjacent. Which one of our trig ratios uses opposite and adjacent? That would be tangent, opposite over adjacent. So I'm going to write this ratio as tangent of 38 equals opposite over adjacent. Now, if I want to solve for x, what I'm going to do is multiply the x on both sides to get it out of the denominator. Now I have x tangent 38 degrees equals 10. If I want to get x by itself, I now have to divide both sides by tan 38 because that will cancel it out on the left side. And I end with x equals 10 divided by tangent of 38. If I put that in a calculator, let me grab a calculator. I find that 10 divided by the tangent of 38 is going to be about 12.79 or about 12.8. In this case, because this isn't really a nice angle, I'm okay with decimals. And no units, of course, because none are given. All right, let's do this one. If I have this as my reference angle, what sides do I have? I have my adjacent side A, and I have my hypotenuse. Which ratio uses adjacent and hypotenuse? That would be cosine. So cosine of 63 degrees is equal to 4 over x. Now notice what happened before here. Well, if you look closely, you'll notice that our x ends up on our left side, our 10 stays where it was, and our tangent ends up where our x was. So my little trick, so that I don't have to solve for x every time, is I can flip x and cosine around. Instead of x being on the bottom, I can write cosine of 63 on the bottom. So now I can throw that in a calculator. 4 divided by cosine 63. Solve that out, and I get about 8.8, more or less. All right, again, no units given, so none have to be added. I know this is really hard to see. I apologize for a poor print job on this one, but this is x degrees, and then on the right side we have 5, and then on the hypotenuse we have 8. So if I am talking about a reference angle here, I have the adjacent side and the hypotenuse. But the difference is this time I don't have an angle. I have two sides. I'm still going to set up my ratio the same way. I'm still going to say cosine of x degrees is equal to adjacent over hypotenuse. Now, in order to solve for x, what I have to do is flip my number in my x. But I can't just make that change arbitrarily. So what I did when I made this inverse was I actually changed cosine. I made cosine into the opposite, the inverse as well. So if I want to put this in my calculator, I'm going to come over here, and what I'm going to do is say second cosine, and you'll see that gives you the cosine of the -1. And then I just type in my number 5 over 8. When I do that, this number is my angle in degrees. So I find that x is approximately 51.3 degrees. Now say on a test I say solve this triangle. Well, that doesn't just mean for x or for y or for an angle. What it really means is to solve and find all angles and sides. So let's make a quick sketch of a triangle here. If we have a triangle ABC, this means that I have to solve for A, B, B, C, and C. All three angles, all three sides. All right, let's keep going. We can also use trig to solve word problems. So I'm going to let you read up here. But the big idea is that angle of elevation starts at the horizontal and goes up from the line of sight. Angle of depression starts at the horizontal and goes down from the line of sight. So let's look at this one here. A 150-foot rope is tied to the top of a 100-foot pole. So let's just sketch that out. There's your 100-foot pole. There's your 150-foot line to the stake in the ground. What is the angle between the rope and the ground? So if this is our theta angle, we're going to set this problem up just like we did the previous page. Opposite side to my reference angle and hypotenuse. When I find those, that indicates I need to use sine. So I'm going to say sine of theta, sine of the angle that I don't know, is equal to opposite over hypotenuse. Now again, I need to switch my theta and my number, but in order to do that, I also need to switch sine to the inverse. So I throw this in my calculator by doing second sine 100 divided by 150, and I get that angle x, or theta, I know I switch variables here, bear with me, but theta or x is equal to approximately 41.8 degrees. All right, let's go again. A car is traveling 750 meters along a ramp, raised 4 degrees from the ground. All right, 750 meters on the ramp. It is raised 4 degrees from the ground. If this is the ground, that means this is 4. How far did it rise vertically? Well, our vertical is here, so I'm going to say x. Knowing that this is my reference angle, I have opposite and hypotenuse. Again, I'm going to use sine. So sine of 4 degrees is equal to opposite over hypotenuse. If I want to solve for x, I need to get that division by 750 away. So I'm going to multiply both sides by 750. This becomes a giant 1. Then I put in my calculator, 750 times sine of 4 degrees. I get 52.3. And that would be meters. All right, last one. Trevor's standing on top of a cliff 200 feet above a lake. All right, here's your cliff. Here's your water. The measurement of the angle of depression to a boat on the lake is 21 degrees. So if my boat is out here on the lake, yes, I'm just going to write boat, and he is looking from the top of the cliff down to the boat. I don't know why it curved there. Sorry about that. It says the angle of depression is 21 degrees. But that is not this angle. That's not that angle. It's actually the angle from the horizontal down to the line of sight. That is 21 degrees. Meaning, if we want to talk about this angle, we have to say 90 degrees minus 21. That then is our inside angle of 69 degrees. So now if we want to know how far the boat is from the base of the cliff, we can say I have this reference angle, I have my opposite side, and I have my adjacent side. Opposite and adjacent is my TOA, so tangent of 69 degrees is equal to opposite over adjacent. Solve for x by multiplying by 200. Throw it in your calculator, 200 times tangent of 69. And we get that it is about 521 feet away. And it says to the nearest foot, so I didn't add any decimals. All right, there are your notes for 13.1 day 2. Let me know if you have any questions.